The problem up on the board is for you folks to try. Y is defined as the natural log of arctangent of x minus natural log cubed of x. This is the same sort of notation that we use with trig functions. This just means the natural log of x cubed. When the exponent comes after the name of the function, it's understood that you're, in this case, cubing that function. Of course, it doesn't make sense to have ln without some input. So you evaluate the function and cube the result. Just like if I have sine squared x, that means sine of x, the quantity squared. Okay, so with that clarification, find me y prime. We can see that y is a difference of two function compositions. Here the natural log is the outside part. Here the natural log is the inside part. So y prime, the derivative of the natural log is the reciprocal. So we'll get 1 over arctangent of x, which has no relationship that's useful at all to arc cotangent of x. The quotient identities and the reciprocal identities are identities for trig functions. They do not translate to the inverse trig functions. Okay, so I've got the reciprocal of arctangent of x, and then I've got to multiply that by the derivative of arctangent of x. Minus, this is the cubing function, and I'm just applying that to the natural log. So I'll get 3 times my input squared, where my input was the natural log of x. And we've got to multiply that by the derivative of the natural log of x. All right, so this is 1 over arctan of x times the derivative of arctan is 1 over 1 plus x squared minus 3. I'm just going to write that as ln squared of x. I can leave it as ln of x in parentheses squared. Either way is correct. And then the derivative of the natural log function is times 1 over x. Okay. All right, if I wanted to write this as, this piece I could write as 3 ln squared x over x. That would be fine. I don't see a whole lot of simplification, though, that's going to make this any nicer. So I think we're done.